This video is on Unit 2, Chapter 4 on complex numbers, Lesson number 3, the complex number system. So this is a new system that we haven't talked about yet. You haven't learned about the complex number system yet. The complex number system includes all of your real numbers plus your pure imaginary numbers. It says consider the number 5 plus 2i. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This type of expression is called a complex number. Standard form of a complex number is a plus bi. The real part must always be stated first, and then the bi, which is your imaginary part, will always be stated second. It's very specific. It must be in that order. So in this first section in our notes, it's called adding and subtracting complex numbers. The directions tell us to simplify the expression below. Final answers must be in the form a plus bi. Now, I works kind of like the variable because it is a variable. I, if you'll remember, is equal to the square root of -1. So I is representing something. It is like a variable. It works like a variable. If I'm going to add or subtract, I can only add or subtract things that are alike. So for example, number 1, it says -11 plus 3i plus 9 plus 2i. So I'm going to add my real parts together. -11 plus 9 is -2. And then 3i plus a positive 2i is a positive 5i. And that's my answer for number 1. Looking at example number 3, there's a minus between. So 7 minus 2i minus 2 plus 6i. And I am going to recommend, just like I've done in the past, that you distribute. -1 times 2 is a -2. -1 times a positive 6i is a -6i, and then we'll combine our like terms. Combine real parts. 7 minus 2 is 5, and then -2 minus 6i is a -8i, and there's your answer on example number 3. I'm going to really quick go through example number 4 because it combines addition and subtraction. There is a minus sign in front, so I'm going to distribute. I'm going to bring down the 6i. -1 times 14 is -14. -1 times -i is a positive I. And then I'm just going to bring down that positive 5 minus 3i. And again, it's just combining like terms. Always start with the real part first. So your real numbers are -14 plus 5, which is -9. And then your imaginary part. So 6i plus I is 7i. Minus 3i is a positive 4i. In the next section, we're going to talk about multiplying. When we multiply complex numbers, it is important that you remember that I squared is equal to a -1. So again, the directions are to simplify the expressions below. Final answers must be in the form a plus bi. So let's look at example number 5. We are going to distribute the 2i into the parentheses. So 2i times 8 is 16i, and then 2i times -3i is -6i squared. And this is where this fact comes back. So the I squared is equal to -1. So this is 16i minus 6 times -1. Well, -6 times -1 is a positive 6. Now, that answer is in the wrong form. The real part must come first, and then your imaginary part is second. So the answer there is 6 plus 16i. Let's jump down to example number 7. You have a binomial, 7 plus I is a binomial, times another binomial, 4 minus I. Some of you might have had an Algebra 1 teacher that used the acronym FOIL, first, outer, inner, last. Some of you may have just had a teacher that said use the distributive property. Either way, it's worked exactly the same. We're going to take the 7 times the 4 and the negative I. And then you're going to take the I times the 4 and times the negative I. So 7 times 4 is 28. 7 times negative I is negative 7I. I times 4 is a positive 4I. And then I times negative I is a negative I squared. And we've got some like terms that we can need to combine, and we need to take care of our I squared. Now, remember that I squared is the same thing as a negative 1. So this is 28 minus 7I plus 4I minus negative 1. So combining my real parts, 28 minus negative 1 means that's plus 1. So I get 29. And then my imaginary parts, negative 7I plus 4I is a negative 3I. So there's your answer on number 7. I'm going to talk about number 9, and then I'm going to work number 10. So on number 9, 6 minus 2I squared means you have 2 of these. A very common mistake among students is to just square the 6 and square the 2I, but that's not how that's worked. You need to FOIL this out just like we did in number 7. I can tell you that the final answer on this is 32 minus 24I, but I want to look at number 10. In number 10, you've got 1 plus 7I times 9 plus 3I minus 4 plus 2I. So the 1 plus 7I times 9 plus 3I is going to look like what we did in number 7. We're going to take the 1 times the 9, the 1 times the 3I, 7I times 9, and 7I times 3I. And then I'm also going to distribute this negative 1. So baby steps. 1 times 9 is 9. 1 times 3I is a positive 3I. 7I times 9 is a positive 63I. And then a positive 7I times a positive 3I is a positive 21I squared. I'm going to keep going. Negative 1 times 4 is negative 4. And negative 1 times 2I is a negative 2I. Now, I'm going to show you my little shortcut. As soon as I see this 21I squared, I know that I squared is equal to negative 1, and negative 1 times positive 21 is going to be negative 21. So to save myself multiple steps, what I do is I mark that out and then add a minus 21 out on the end. So I take care of those squares as I'm working, and then all I have to do at this point is combine all my like terms, starting with my real parts. So 9 minus 4 minus 21. 9 minus 4 is 5. 5 minus 21 is negative 16. And then my imaginary parts, 3I plus 63I would be a 69I minus 2I would be a positive, 66 minus 2 would be 64. Sorry, I said that wrong. I caught it. So there's your answer on number 10. Moving right along to complex conjugates. So in the notes here, right here, it tells you that 2 complex numbers in the form a plus bi and a minus bi are called complex conjugates. So this is vocabulary that you need to be familiar with. The product of 2 conjugates is always going to be a real number. So what happens here is that the i's go away every single time. But you have to be multiplying complex conjugates. And if you look at these on number 11, you've got an 8 plus I times an 8 minus I. Those are complex conjugates. Number 12, 5 minus 4I times 5 plus 4I. Again, those are called complex conjugates. And I've written a little notation here. The signs change on the imaginary part only. So with your complex conjugates, only the sign on the imaginary part is different. They're opposites of each other. So I'm going to work number 11. Same process as you saw on the previous page. 8 times 8 is 64. 8 times the negative I is negative 8I. And then the I times 8 is a positive 8I. And then I times negative I is a negative I squared. So notice here in the middle, this is why the i's are going to go away and you're going to be left with just a real number answer. Your negative 8i and your positive 8i are going to subtract out, and that happens every time. Your I squared is a negative 1, and negative 1 times the negative 1 in front is going to change that to a plus 1. So 64 plus 1 is 65. And that's how we multiply complex conjugates. And again, they always will be a real number. Now let's talk about dividing complex numbers. In the notes here, it says, watch out. I cannot be in the denominator of a complex number. And the reason is because I represents a radical. I represents the square root of negative 1. And you would have learned in Algebra 1 or geometry that we are never allowed to leave a radical in the denominator. So number 13, I rewrote it. Instead of using the I rewrote it using a radical. You would have learned how to rationalize a denominator back in geometry. So that's why you cannot have an I in the denominator, because I does represent a radical and we're not allowed to have radicals in the denominator. If the denominator is a monomial, multiply the top and the bottom by just plain I. If the denominator is a binomial, we're going to multiply the top and the bottom by the conjugate. So let me show you an example of both. In example number 13, the denominator is a monomial. No pluses, no minuses. It's just one term. It's a monomial. So what we're going to do here is we're going to multiply the top by an I, and we're going to multiply the bottom by an I. Now what happens is, with fractions, we multiply straight across. So 10 times I is 10I, and then 2I times I is 2I squared. Now let's reduce. 2 goes into 10 5 times, right? And then I squared is equal to a negative 1. So I have 5I over negative 1, which I don't like negatives in the denominator. Never leave a negative in the denominator. Plus the denominator is a 1. So my final answer here is just negative 5I. Let's look at number 15. Number 15 says 28 minus 8I divided by 4I. The denominator is still a monomial. A 4I is one term. It's a monomial. We're going to work this like we did the last one and multiply the top by an I and the bottom by I. So we're going to distribute in the top. 28 times I is 28I. Negative 8I times I is negative 8I squared. And then 4I times I is 4I squared. So for this one, your numerator is a binomial. It's going to be a little different than example number 13. I'm going to walk through this very slowly. I'm going to first change my I squares. So in the denominator, 4I squared, because I squared is equal to negative 1, and 4 times negative 1 is negative 4, I'm going to change my denominator to a negative 4. In the numerator, again, I squared is negative 1. Negative 1 times negative 8 is a positive 8. So I'm going to just cross that out and put a plus 8 there. Now, look at your numerator. 28I plus 8. I'm going to reorder this into the correct order because remember, your real part comes first, your imaginary part comes second. Now, two things. There is a common factor. We want to look for a common factor in all three parts, 8 and 28 and 4. What goes into all three of those numbers? Well, 4 does. And specifically, I'm going to use the -4 because there's a negative in the denominator. So what is 8 divided by -4? Well, that's -2. And then what is a positive 28i divided by -4? Well, that's going to be -7i. And we just got rid of our denominator because -4 divided by -4 is a 1. And we don't put denominators of 1. Number 17, 18, 19, and 20 are all similar. So if you look at these denominators, the denominators are not monomials. The denominators here are binomials. When your denominator is a binomial, what you have to do is multiply by the conjugate in both the top and the bottom. So looking at number 17, I've got -2 divided by 5 minus I. So to fix this fraction, we're going to multiply the top by 5 plus I and the bottom by 5 plus I. So in the numerator, it's going to say -2 times 5 is -10. -2 times I is a -2I. In the denominator, you've got to go through that process like what we started on the other page. Some call it FOIL, some just call it distributive. 5 times 5 is 25. 5 times I is a positive 5i. -I times 5 is -5i. -I times I is -I squared. So very quickly, I'm going to fix my bottom. Those are going to subtract out. And a -I squared is going to change into a +1. And again, y'all, it's a +1 because I squared is equal to -1. There was a negative in front of it, and that's going to make that +1. So my new fraction becomes -10 minus 2i all over 26. And I'm going to point out these three again. We're looking at the -10, the -2, and the 26. Is there a common factor? This is how you have to look at how to reduce this fraction. Is there a number that goes into all three of those? It has to be all three. 2 goes into all of them. -10 divided by 2 is -5. -2 divided by -2 is a positive. Actually, I'm not dividing by -2. I'm so sorry. We're just dividing by 2. -2 divided by 2 is -1i. And then 26 divided by 2 is 13. So there is our answer for number 17. I'm going to do one more. Number 19, 7 plus 3i divided by 2 plus I. So the 2 plus i's in the denominator, it is a binomial. So I need to multiply both the top and the bottom by 2 minus I, which is the conjugate. And we're going to be doing FOIL to both the top and the bottom. So 7 times 2 is 14. 7 times -I is -7i. 3i times 2 is a positive 6i. 3i times -I is -3i squared. And immediately, I'm going to change that to a +3. And I'm going to get rid of that. And that's going to help me in my next step. In the denominator, 2 times 2 is 4. 2 times -I is a -2i. I times a positive 2 is a positive 2i. And I times -I is a -I squared. And again, I'm going to immediately change my I squared. I squared is -1. -1 times -1 is a positive 1. So combining my like terms in the numerator, my real parts are 14 plus 3. So I have 17. -7i plus 6i is a -1i. And then in the denominator, the -2i and the positive 2i cancel. And 4 plus 1 is 5. Now, that is actually your answer. But I do want to point out that technically there's a 1 in front of that I. And what I was showing you earlier was you have to have something in common with all three pieces. And they do not have anything in common. And that is why your answer on this one is the 17 minus I over 5. So those are your notes on chapter 4, lesson number 3.